In the last video, we talked about measuring rate by the amount of gas produced, the volume of gas produced. Okay, so we had measuring the volume of gas produced. Now, in this one, we're going to talk briefly about something similar, but instead of measuring the volume, we're going to measure the mass of gas produced. So let's suppose we have let's do a different reaction. Let's do calcium carbonate plus HCl. Okay, so a metal carbonate plus an acid gives us a salt. Now, calcium is in group 2, so it's Ca2 plus. Chlorine is in group 7, so it's Cl minus, so it needs to be CaCl2 plus water plus carbon dioxide. Okay, and is the reaction balanced? Let's have a look. Not quite, so I need to have a 2 there, and that's balanced. Now, we're going to measure this. Now, we could do it using a gas syringe if we wanted to, but we're not going to do that this time. This time, we're going to measure the amount of mass of this. Okay, and we're going to do it in a slightly clever way, because if you had, imagine your conical flask again, right, and inside your conical flask you've got your HCl and you've got your calcium carbonate, be a white powder, all right, and you're producing CO2. Now you might be thinking, well, if we want to measure the mass of this, we're going to have to collect it and then measure how much what the mass is. It's not what we're going to do. There's actually a cleverer way to do it, and that is we're going to, because the gas is being lost, right, it means that if we measure the mass of this should decrease. Because as the carbon dioxide gas is produced and it escapes, the mass will decrease. So we're going to use an experimental setup that looks like this. Okay, so what we have here is our calcium carbonate in our hydrochloric acid in a conical flask on a weighing scales. All right, and then as the carbon dioxide is produced, it escapes out of the conical flask, and the measurement here the mass here will decrease. Okay, and that will be equal to the amount of carbon dioxide produced. So if the mass goes down by 0.1 grams, it means I've lost 0.1 grams of carbon dioxide. All right. Now there is some cotton wool in the neck of the conical flask here, and the purpose of the cotton wool is to make sure that only gas escapes, to make sure that there's no liquid escaping. Because obviously if some of the hydrochloric acid escapes as well, that's going to mess up our results. All right, because we only want carbon dioxide to be escaping. All right, so we need to draw our experimental setup out again, and just to make sure it's as it should be. So it should look quite a long neck of my conical flask there. It's okay. All right, so it looks like this. Okay, so this is a mass balance. This is a conical flask, conical flask, and there will be some cotton wool. Okay, so only gas escapes. All right, and then that's my reaction in there. Okay, now you will need to be able to draw all of these experimental setups. Now we'll do the experiments, which will help you remember, but you need to be able to draw that, and you need to be able to draw that, and label it, and rationalize it. You know, why do I need the cotton wool here? Well, you need the cotton wool there, so there's only gas that escapes. Okay, okay, so let's suppose that we did this reaction, and we came up with this table here, this table of results. Make it a bit clearer. Okay, so we measure, as the time goes on, we measure the mass on here. So this scales here at the start would have, 200 grams. And we put the calcium carbonate and the hydrochloric acid in to the conical flask, and then or we should have had, there should be an extra one here at 0. But anyway, let's not worry about it. We'll worry about that when we do the experiment for real. So let's say we measure the time and we measure the mass, but we want to know how much mass of carbon dioxide is produced. So what we can do is, well, at the start it's going to be 0, but then from 0.5 minutes to 1 minute, my mass changes from 200 to 198. So how much carbon dioxide has been produced? Well, it's just 200 minus 198, so it is 2 grams. And then, there's where you need to be careful, because you might think, well, it's 198 to 196, so it's 2 again, but that's only from 1 to 1.5, whereas I want the total amount of carbon dioxide produced. So I need to look back to the very start, so I've gone from 200 to 196, so I've made 4 grams. 200 to 194, I've made 6 grams. 200 to 193, I've made 7 grams. So you can see how by measuring the time and measuring the mass, I can work out the mass of CO2 produced. All right, and then obviously I can take that data and I can, like I did in the last video, I can plot a graph of, now it's going to be time against mass of CO2 in grams, okay? And that would look very similar to this graph up here, and all the same principles would apply. Okay? Excellent.